Let's make Labyrinth. This could be your first game in Unity. Let's learn how to make it. In this video, we will learn how to make your first video game. You will be learning Unity 3D programming in this quick tutorial. The game we're making is called Labyrinth. It is a puzzle game where we have a wood plank and there are some walls as a puzzle and there are holes in the middle. You will be actually balancing the board to move the ball, avoid the holes and reach a target. This is the game which will allow us to learn how to actually set up a game scene, how to put objects in the scene, how to add gravity, how to add physics, how to handle the collision, how we actually have game success, game over, and eventually a lot more. A little bit of a computer programming will be added to actually have inputs. So we will be handling keyboard input for up, down, right, left for balancing the plank if you're playing it on the computer. And if you're playing it on a mobile phone, we will be using the device to actually balance it using the accelerometer. So we will learn how to port your game to PC, how to port your game to web, and how to port your game to a mobile phone. So let's get down to the tutorial. Alright, so we are starting to make our Labyrinth game in Unity 3D. This is a new instance of Unity. We just started a new project. If you don't know how to download Unity, I have another video linked below in the description and here in the video as well. You can watch that video to see how to download Unity. You download, install Unity, run it, and this is the first new 3D project we have created. To make Labyrinth, we need a board, a base board, and there will be holes in that board, and that board will be made up of wood. I really don't want to make the whole board in one piece, and we will try to use only the objects available in Unity 3D so that there are no assets to be created in a third-party tool. So we start off with setting up the scene. You can see that whenever you start Unity, it gives you one default scene in the scenes folder called sample scene, and on the left there is this sample scene which is open, and inside this sample scene hierarchy you will see a main camera and the directional light. I'll leave the directional light as is, but I will put my main camera at position 0, 0, and its position is going to be above ground, so y-axis is going to be like, let's say 20, and this is going to be facing down, so we will rotate this down to 90 degrees. So it's literally looking down. Then I will create my first game object, which is a 3D cube, and put it at position 0, 0, 0. So when you click on the camera, you should be able to see the small cube down there. This is the base cube we're going to use to actually make the board, and we will actually increase the width and height to something equal. For example, I can make it like a 5 by 5 cube, and you can see from the camera that this is going to look like this. What I'm going to do from here on is actually make several of these cubes to make the whole board. It is a good idea to set things up right now to make sure that you're going to play the game correctly. So in the game mode, you can go set the aspect ratio to something 16 by 10 or 16 by 9. So this is how big your screen is going to look like, and your board is going to be down there. What I'm going to do is I will make the whole base board made up of around I don't know, 8 by 8 of such cubes. So this cube looks a little too big for that. So if I change the size of the cube to, let's say, 2 by 2 like this, and I can try duplicate it and move it a little to, let's say, position 2, and duplicate to position 4. In the scene we can see this happening. I can select, or I can duplicate this again and move it to position 6. Also, I can duplicate them all and take this thing down to this place where the position is -2, -4. We'll need to be a little more precise so that everything is on the right place. So this is -8. If I look from the game, this looks decent. So this is our probably the center bar. I'm gonna probably change them later, but I'll actually group them together, or yeah, let's make a game object empty. I will call it a column maybe, and put all the cubes under this column. So what happens here is that the column is at position 0, 0, 0, and I can actually move the whole column together. I can now duplicate this column and move it this way to position -2. When we make -2, there's going to be no gap. I'll do this again and change position to -4. Sorry, what I'm going to do is, yeah, this is going to be -4x. Let's do it one more time and make it -6, and then I can probably duplicate all 4 columns to make it like this. So this is going to be a different column. So column 5, 4, 5, 6, 7 are the last ones. The position is 2, position is 8, position is 6. I'll have to do a little bit of hard work to make them absolutely precisely at the right position. And now we have a board. If I look from the camera, this is how the board looks like. Now I'm going to make another empty object and call it the board. And I will put all these 8 columns, where every column has 8 tiles, into one board. And this is my whole board now. I can move the board to move the board. The position is 0, 0, 0. So the idea is when I rotate the board now, it is going to tilt in all the 3 axes. We will not rotate it around y axis, but we will rotate it around x and z axis to make the game work. Now the board is fine. We will need 4 walls and some puzzle walls in the middle, and some holes, and obviously in the end we need a ball. So to make the walls work, we could probably use the same object, which could probably be used as walls every now and then. Then there will be a starting point, there will be an ending point, and eventually we will have a good puzzle working. Alright, next thing we're going to do is make this thing wooden. This is pretty bland gray, and to make that happen, I have this small image here, just downloaded from the internet, from stock photo website. I will simply drag this image from my desktop onto my Unity folder, not in the scenes folder. Maybe I could take it to the assets folder, and I'll literally go drop it onto all these boxes. I should have done that before. If I do this now, it is going to apply it to one box at a time. So this is going to be like a wood texture on all these 64 box cubes. Okay, once I'm done applying all these textures, you must be thinking, why did we even bother going to a detail where we're breaking this down into 64 boxes or 8 by 8 grid? The important point here is that we will actually replace some of these boxes with a hole so that the ball could run around. Let's probably add a ball right now. I go to game object, 3D sphere, and it will create a ball for me somewhere down here. Let's take the position of this ball to position 0, 0, 0, and then we move this up a little to this position. Now when I run the game, this ball should drop, but it will not because we do not have a rigid body in this. So I will click this sphere, rename this to a ball, and I will add a component called rigid body, and when I run this game now, the ball is going to drop. Tapak. Okay. It doesn't look very clear from the top, but the ball was higher. If I take this ball closer to the camera and run the game, you will see the ball going down. There it goes and drops. Alright, so I really don't want the ball to drop usually. It is going to be on the surface already. What I want to do is, if I run the game, and for now I can manually rotate the board a little to see how it works. So if I rotate it around X, this is how the tilt looks like, and this tilt is actually causing the ball to roll. So we will actually add some controls using some code where user presses some input keyboard or uses the accelerometer on your cell phone, and this should allow us to move the ball like that. Also, I could use the Z-axis to move this same ball sideways, and this is already looking pretty natural. One more thing we can do is looking at the ball, and its material is right now a default material. What I'll do is I will right click, create a simple material, and it's okay if the color is sort of gray, but I want to be way more metallic, so I will change the property of this metallic ball to be way more metallic like this. And once this happens, I will drop this material on the ball, and this ball now looks it's too metallic. Maybe let's reduce it a little. Yeah, so this is a metal ball. I'll change it to whitish. I could make it a little greenish metallic, or a red metallic, or a orange metallic, which could probably turn a little golden later on. Yeah, this looks neat. Or I'll just stick to the white. Yeah, this is better. Okay, so now when I run the game, and right now my board is not moving, but if I use my properties to rotate the board, this is going to rotate my board accordingly, and this rotation could make my ball go here. Oh, too much. Let's start again. Yeah, so if I tilt the board accordingly, this should rotate the board and cause the ball to move a little as per the rotation. Whoa. Okay, let's stop. Now the ball is right now like that. Yeah. Now what next? Now we need to make some walls for this game, and once again we will probably use one of the cubes or make a new one, game object Q3D cube or a cylinder. Let's keep it a cube already, and I'll definitely add the wood to it before I do anything else. I will reduce it in size but increase it in one of the length, and first thing we need to do is probably make the wall higher and make the side walls. I don't want the ball to fall off the borders, so the size you can see is increasing in scale here. So this should be 16, Probably it should match the size of the board. It's a little too thick, I can make it thinner, but too high, a little smaller, and probably we are good to go. We'll try to keep it a little too precise, but well, when the carpenter is making something like this, there may be a little imprecision visible some places, so it's okay in that case as well. Also, I'm gonna duplicate this, so let's call it a wall, and let's call it a wall 2. So I could actually duplicate these two and can rotate them around for 90 degrees, and this should probably give us something like, now let's place them at the right place manually. Good stuff. So now we have border walls. Let's see if these borders wall will be able to prevent our main ball to move out from moving out of the board. So let's see how it goes. I will just make sure these walls are also children of the board. Let's tilt the board a little as well. When I run this game now, you will see the ball is rotating and it hits the wall, but the wall is a little too low and it jumps over it. So what I'm going to do is select these 4 walls and increase their height. What's going on? So the height of this, yeah, I've rotated them around. So the scale in a Y is 0.43. I will make it like 2. Is that too much? 1. Let's try that. And if I do that for all the 4, this is how the walls look like now. Is that going to stop the ball from jumping off? Maybe the scale of the ball is too big as well, so we can reduce the ball size to probably 0.7 as well, because the labyrinth ball is smaller. And this is a good board, good ball, physics implemented, rotation is working, and I could actually rotate it on other axes to see it rolling otherwise as well. Yeah. Good stuff. We can actually use the same outer walls to make inner hurdles as well, but before we do that, it's important to actually replace some of these boxes in the middle with holes. Let's see how we do that. To make that whole thing, I'll probably copy one of these cubes and take them out of the board and place it separately somewhere, maybe over here. This is going to be used for reference of the size purposes. I'll probably duplicate this out. Oh, hang on. Let me put the rotation back to 0, otherwise it's going to be a pain. So my board is unrotated now, and my board has one of the boxes. I'm going to duplicate. I'll put it somewhere over here. It's out through the board now. Yes, I'll use this as a reference. How do I use it as a reference? I'll probably make 4 cubes out of this and reduce their size to like very thin. I know this is not going to be a round hole, but at least it's going to solve the purpose. So its scale, you can see, is 2, 1, 0.27. So let's make it 0.25. Okay, I'll duplicate this here. move it here. So I'll move these two fellas onto this cube so that I can actually make sure that the size is pretty accurate. So I put it here and I put this one over here. I'll probably duplicate this one and rotate it around the y-axis to make it 90 degree and precisely put it on this side of the cube. Please note the cube or the sphere that you create inside the Unity has its own collider. So these green thin lines you see are actually colliders. That's why the ball is going to collide with the rigid body. I will duplicate the fourth wall. So I actually made 4 blocks out of this reference cube. I can delete this cube now, and this is actually my not so cool looking hole. Also, if I want, I can add some beauty to this by adding a few more pieces, but first thing I need to check is that ball gonna fit? And you can see that the ball is pretty small as compared to the size of the hole, so this is going to be all good. Okay, what else I'm going to do is probably do a little more trick here. Duplicate this cube, turn it 45 degrees, resize it a little to, let's say, this big now. Make it 1. Yeah, this looks better. And I'll probably try to make it more of a slight curve. I know this is not round, but I just want to keep things simple. Yeah, 0.7 will do. So this is actually a wooden edge which is not round, but it is better looking. I can duplicate this, bring it here, rotate it to 135 maybe. Similarly, bring it here and take it back to 45 and make it here. Yeah. So this is my cube with the hole. Cube with the hole looks fine from all sides. Once again, I will check the size of the ball. Is that going to fit in? Yes, it will. Thank you very much. Dear ball, go back. And now, all these cubes actually could be called a hole. So I'm going to make game object, create empty. I'll select them all so that the empty object comes in the middle. Yeah. So this is called a hole. I'll put all these cubes inside the hole, and now I can replace some of the cubes with a hole. Nice. So for example, I can take out this guy and have a few holes ready for placement in there. I could take this hole and place it right here. I know we can be a little more precise, but I'm just going to be quick and move some of the holes out and replace some of the holes back here so that I have the surface ready for the board. I'll obviously get rid of the boxes I'm removing. They probably could be placed in the right column, but it's sufficient to be placed under at least the board. If they actually become the part of the board, this is going to be sufficient. Let's see if we can continue doing that. So let's remove this, take a hole from here, bring it in, place it here, precision a little, join it from here, good stuff. And I'll probably remove this one, replace it with this hole here. Once you learn more of scripting, you could actually design these subcomponents, put them down as what they call it, a prefab, and instantiate those prefabs and design your level as probably a text file or a JSON file, and can instantiate these holes and cubes to make a level. But for now, we're just doing it literally, all of it manually. We already have quite a few holes in this level. Is that sufficient? We need more holes. Let's remove this one. Yeah, this is going to be good. This hole could come here. Oh, finally this one is a good idea. Let's go for this final hole here. Just for the housekeeping, please note all these holes are not children of the board, and these cubes were. I'll get rid of the cubes and put the holes as a child of not any column but probably just the board. So I'll drag these holes into the board. Now if I rotate the board, the holes are rotating along with the board. And if I run the game now, come on. Oh, it's already dropping into the hole. Yeah, it's a little too big of a hole for us for now, but well, we know what we're doing. Now we need a little bit more of work when we say that we need to have a starting point. Let's say the starting point is the top left corner here, and the ending point is here. We used to have an old-fashioned thing called 3D text, and I can use that right here. And in this, if you look at this 3D text, it right now looks like hello world. I will change it to start, change the color to, let's say, something more funky, yellow, or red, green, orange, increase the size somehow. So font size is going to be a little big, and I will rotate this literally to land on the starting box that we wanted. So this is start, rotate it down to, let's say, 9000, and place it here. Also, it's a little low. I'll also reduce the size now to fit here. has to be slightly above the board. So now I run the game, you should see, oh, make sure whenever you're making a game you just stop playing, otherwise you will lose any work that you have done. So my 3D text is gone, I'll do that again. 3D text, start, yellow, font size, rotate down to 90 degrees, reduce in size, and this is a good starting point. If this is a starting point, we will put the ball here as well. Somewhere slightly above this, like that. So when I run the game now, the ball is going to be right there at the start. Looks good. If this is the starting point, we could probably have a finishing point somewhere over here. Let's turn this green, and we have start point and an end point. Also, now we'll start designing my level. I will probably duplicate these walls. This could go here. So now it depends upon your creativity. I've not spent much time drawing this on the paper, so I could probably be making something less fun, but you'll get the point once this is ready. All these walls. It should go drop onto the wall. Next thing, now we need to do something to rotate this board. Here's the time when we'll need some a little bit of coding around, so we will add some script to this board. I click on the board, add component called board script. That is going to be my new script. Create and add. Double click on that. This should launch your editor, which is usually by default your Microsoft Visual Studio. This installs along with your Unity. So this is your code that you already get pre-written. All we need to do is check for the keyboard input right, left, up, down. If input.getKey, key code, dot left arrow. If it is left arrow, do this. If it is these are 4 of the arrows. I'm going to copy paste. Left arrow, right arrow, up arrow and down arrow. So let's double check. If I want my board to go tilt right, something like this, I need my z-axis going in negative, and for left z is positive. So for right, so it's going to be transform dot rotate 0, 0, 1, and it could be 0, 0, minus 1. 1 is a little too big for this, but let's see how this behaves. I run the game. If I press right, whoa, you see it's going a little too fast. So what we can do is stop the game, go back to the code, make it like 0.1, actually it should be 0.01, should be minus 0.01. Also, this should actually happen in your fixed update. What do you mean by fixed update? If I used only update, this will actually update every time your game runs 1 frame. So if your game is running at 30 frames per second, it is going to be updated 30 times a second. If your game is updated 120 times a second, update will run 120 times. So the behavior of the key press is going to be different. Fixed update is it's going to update n number of times, a fixed number of times, regardless of the computer speed. So if your machine is faster or slower, it's going to do the same thing. So let's try it now. If 0.01 is too small, so if I press left, it is slowly tilting. It is, but it is a little too slow. Let's see if 0.05 will work. So it's a bit of a hit and trial to see how well the board will move with 0. This looks decent, but we need to speed things up sometimes. I think it's going to be more fun with the accelerometer, but I'll change this to again 0.1 to see how it behaves. Hopefully it's going to be fine now. And for up and down, it's going to be the similar kind of a code as well. So left, right, left. This is better, and I'll do the same thing for. So if this was z-axis, this should be x-axis now. I can double check. My board needs to go this way with up, which is positive in x. So this is going to be in x, positive up arrow, transform dot rotate 0.1 f 0, 0. This f is for float. Floating point numbers are the ones with the point. This got to be minus 0.1, and I think we have a running game. So I run the game, I move it a little low, and this starts rolling. Now I need to take it right a little, and oh come on, okay, let's do this again. So nothing happened, the ball went down, but the game wasn't over. And also we need to do something to check how will the game finish. Okay, I avoided this just fine, and I could not avoid this one. Okay, now I need to do something that when the ball goes down, I should say game over. One of the things I could do is I could put something invisible at the bottom. When the ball hits that, I could say the game is over. Or right now, one of the things that is happening is my ball is at position -7, which is like X and Z. But what I'm more interested is in position Y. So if somehow the ball reaches this position, which is -2 or -3, I could simply say, man, the game is over. The ball cannot come down here without you're going through a hole. So I'm going to do this. I will add a script to the ball. Select the ball, add a script. Let's call it a ball script. And when I open the boll script, it's going to be empty again. I will, on every update, I will check if boll's transform dot position dot y is below -2. I'm done. This is game over. What do we do on the game over? I'll probably do one simple thing. I'll just change the scene to another scene where we have written game over on the screen. So for that, I have this little image I just downloaded from a website called freepic.com. I will drag this into my Unity again. Also, I will save this scene, make a new one, and I'll simply make a game object 3D a quad. Quad is this just a 4-corner plane thing, and put this game over thing on that. Also, I will place it in front of the camera, so let's make it 0, 0, 0. My camera can probably see this, but not very clearly. I will resize it accordingly, and also I will change the property of the shader from standard to, let's say, unlit texture. This is going to make it more shiny. When you see this, this is what you're going to see. I'll just manually place my camera or the quad in a position where it becomes more covered on the screen. Okay, this looks better. A little bigger as well, and we're good. This looks fine. Yeah, game over. And this scene I will file save as in my scenes folder. I will call it game over. Now I have two scenes. One of the scenes says game over. It's in this. Another is called sample scene. I could probably rename it to main scene. The following open scenes have been changed. Yeah. Oh, what did I do? Damn it. This. Okay, main scene. This looks good. This looks good. So game over scene and the main scene. Now when my ball goes down, I should come to the game over scene. What I can do is I can add a library, Unity engine dot scene management dot, and I could say scene manager dot load scene, and the name of the scene was game over. But this is not going to work until and unless we start working on the build that I have these two scenes to go to the, so when you finally build your game for the mobile phone or for the web, this needs to be in the build. So what you need to do is file, build settings, and you will drop these two scenes in here, probably main to be the first one and game over to be the second. Okay, that's it. Now when I run the game and try to intentionally drop this fellow down the hole, it goes down to -3 and says, voila, game over. Okay, what else? Now we need to do something when my ball reaches the point here at the end. So maybe I can cheat a little, bring this here, and when I hit this start, it should not say start anymore, it should now say finish. And once the finish is a little too big, we can reduce the size. Okay, this is how it looks, not too bad. Now I want my ball to hit this finish, and once I reach this place I should say, yay, I win. Okay, for that I need something here which it hits, and we decide that okay, we've reached. I'm just going to make at this finish point, I'm going to make an empty object. should be here somewhere. You can see it was down there. Why an empty object? I don't want anything visibly here. Also, I will add maybe a sphere collider or a box collider. So this invisible green ball you can see over here. Once you collide this, you will actually get this code working for us. The name of this is going to be finish object. Now my ball has a rigid body. If it collides with another thing, it should get some notification in the code. And the code is called on collision enter. So you add this function in addition to the start and update, and I say if collision.gameObject.name.equals starts with, what is that, finish object? What do you call this fella? The empty object I just made. Yeah, it is called finish object with a capital F. If this is the case, you win. So what do we do with a you win thing? It should be similar thing that you go to another scene probably where you say you win. You win is no scene in my game right now, but I can make one. I'll keep it very simple. File, new scene. Yeah, save it. I'll call it file save as. You win. And in the you win at position 000 or maybe in front of my main camera, I don't know, I'll just put an empty a 3D text that says you win in probably blue. This blue text, blue, come on blue, yeah, this blue text should be a little bigger and it should be in front. How does it look? Doesn't look like it's visible. So I can take it to position 000. Where's my camera? This is my camera. Yes, it is becoming visible. It should be right here. Too big. Okay, I'll just be happy with this kind of a weird you win. Obviously you can do more stuff to make it more beautiful, maybe have a try again button later on added to this, and more details if you want. So I will call this to be a you win scene. Also I'll save this, and in the file build settings I will also add this you win here. Alright, now what happens is when you reach the finish and hit that fellow on the invisible circle finish object in the main scene, we should have a change in scene. Let's check. I'm gonna go down slowly, come on, go hit it, and you win. So if you actually succeed in doing this, you have a working scene with quite a difficult stuff happening here, and with the keyboard it's a little difficult to handle, but well, come on, that's what the games are all about. The games are supposed to be tricky, they're supposed to be difficult, so we have to take this path. Oh, you see, I'm dead. Let's start putting the ball at the original position. I don't want to attempt, sorry, it's going to take a lot of time with the keyboard, but let's see. Let's put it on the start. I'll attempt once or twice, and then what I'm going to do is I'll put this on a mobile phone with an accelerometer to make it a little more usable, because with the tilt, amount of tilt of accelerometer, we will change the amount of tilt of the board. But anyway, we are just learning. Oh, come on, don't do this. Okay, I avoided another hole, and let's do this way. Is it stuck? No, it's not stuck, but it is. Okay, let's see. Oh, come on, don't go back. Come on. Now you can go back. Yeah. What's up? Is it stuck somewhere? Yeah, it's getting stuck a little. Let's see what's wrong with the collider, but for now I want to try avoiding this hole. Okay, good. Let's not get into that hole this time. Oh, come on! Oh, game over. Okay, this is actually some fun game. Now, once we have this game working, obviously we can do more with the aesthetics. We can add some cool background. This looks pretty blank and bland. We can do more stuff, but more importantly, we will learn two more things in this tutorial. We will port this game. Obviously this game is ready for PC. We will make an exe file for this so that you can send it over to your friend to actually play it. Secondly, we will learn how to put this game on the web. Just make an HTML file out of that. And thirdly, we will deploy this on a mobile phone that is going to be an Android phone for simplicity. So let's get down to that business. Alright, one quick thing we should do before we port it to different platforms is make it more playable when you run out of the game. So for example, if you win or if you lose. So from game over, you will see this game over forever if you're playing on the game on the mobile phone. Maybe over here somewhere we could have a button which says like play again. Similarly, in the you win, you could have a button here which says play again. Only thing that is going to do is load the scene again, this one line with the main. So let's try doing that for the game over scene first. For user interaction and user interface, we have UI components like buttons and sliders and whatnot. So I will go into the game object and I will use UI and grab a canvas. Canvas is the place where we put things. In the scene you will see this big huge canvas box showing up. So my screen is 16 by 10 landscape, so we should remember that. Also in this canvas I will look for the screen scaling, the UI scale mode to be scaled with the screen size. So if you play on a 4K or a 1080p screen, it is going to actually scale accordingly. So I will call it 1920 by 1080 to be my reference screen size, and on this screen I will just add one button. That's it. So you can see the button is right in the middle. I will anchor it to the bottom right and I will place it somewhere at the bottom right as well. If I go closer, you can see this is how the button, oh, it is on the right. This is what the button says. So right here in the game you can see this button here as well. I need to increase the size a little using this 2D resize tool, rect tool they call it, something like this big. And I will change the text which is inside this button and increase the text size to be bigger and say play again. So this play again button is now here, when you run the game, or you run this scene, this button you can see is clickable. You can make it more pretty, change the colors. Instead of this clickable gray button, you could add a more colorful button later on. But here, this play again button is here for us. How do you put code behind this? We need some object where we add some script, obviously. So I will create a game object. Let's call it UI script object, and in here I will add UI script. In this UI script, whenever somebody clicks the button, I will call this function. So I will call it public void go back to main. Remember this, go back to main. And I will literally copy paste this line and paste it here. So instead of you win, you're going back to main. So the idea is, whenever you come back to this scene, you click on this, play again, and it takes you back to the labyrinth scene, main game scene. One thing which is missing now is connecting this play again button to the UI script. My UI script looks like this. It is giving me an error because we have not included using Unity engine.scene management here. Now this error is gone, so my script is done. So this UI script needs to be connected with this button. So I click on this button, and down here, let me move my video a little. Now you can see there is an on-click portion here, and there's a small plus sign. You click on that, and you need to add an object. So I will select the UI script object from here, or easier thing to do is literally drag my UI script object from here in the scene onto this box. Now there are no functions written here, but if you drop down, you will see my functions here. Inside the UI script, I created one called go back to main. When I click on this, my linkage is now complete. So if I'm on this scene, when I click on play again button, it will take me to the game. Once the game is over again, I will be back onto this scene again, and this play again will take me back to the game again. We need to do something similar, so let's save this scene. We need to do something similar onto the you win scene as well, which doesn't look very neat, but this is what my scene is all about. We will actually add a canvas here as well. So a game object, do the same thing over again, grab a canvas, scale it to the screen size. Now click on the canvas UI and add a button. Button. Okay, here's the button. Now my button is here and my canvas is there. Put it on the bottom right again, maybe place it accordingly. This one is looking bigger because my canvas reference resolution is 800/600. Let's make it 1920 by 1080 because a lot of phones and screens are actually that size. On the button, I will increase the button size. I will increase the text size as well, which is the child of the button. Increase the font size to something bigger and say play again. Now you can see that the play again button is here. It's clickable, but we don't have that connected. I will go make an empty object. I'll call it something else, UI object, UI script object. It's something of your personal choice. Add a component and don't create a script again because we already have a UI script. And then from this button, at the bottom, on click, press the plus, drag this UI script object into the box, and select this go back to main function here, and we are good to go. So if you are on this screen, which is you win, play again, I can click on the play again and I'm here. I can now actually try losing the game to see if I go to the game over scene, and if I go to the game over scene, I should be able to play it again. Game over, play again. Good stuff. So we are all good with restarting the game. So now let's start porting it to different platforms one by one to see how it works. So first of all, I want to make a Windows port. If I go to File, Build Settings, you must have seen these three scenes added over here, but we have PC, Mac OS, and Linux standalone. This is already the case. I could actually make a build and it's going to make me an exe for the PC. There is an iOS version, Android version, WebGL, tvOS, PS4, Xbox One, and whatnot. So we are already on PC. We don't need to switch. And let's try to make a build. For the build to happen, we need a folder where we're going to make this build. So maybe I go create a folder here called Windows Build. Let's see if I can Windows Build. Let's see if I can put my exe here. So I go to Unity, I click Build. It is going to ask me, where do you want to put this? I go to my desktop. I go to my desktop, select the Windows Build folder, and here I select this folder. So now looks like it has actually started building for me. Depending on the speed and capability of your system, this should take a bit of time to build for your Windows version. So this is literally the labyrinth.exe independently of Unity. I can double click on the exe and here we are on Windows. You can send this exe to anybody. Use your keyboard to make this game work on your Windows machine. The game over, I can play again. Okay, so this is working. Alt enter to come to the window mode and close it. Now to make the same thing work on web, I could probably make another folder here. Maybe inside the Windows build I can make a folder called, no, let's make an independent one. Web build. I go to Unity and this time I click on WebGL, and this time you can see this build button has changed into switch platform. So I will click on the switch platform. This will change a lot of stuff in your whole platform and make it compatible with the WebGL. Once the conversion is complete, you can see even the code is being edited a little. Apparently we're done, and now I can click on the build, and instead of I go to my desktop, web build, and I select folder, and it should actually start building it for me. This build is going to be a folder and a few files, including the HTML file, and this HTML file will be available. You cannot open this HTML file directly on your PC. This has to be uploaded somewhere on the web server. I'm going to put that on the web server and put the link in the description. You can click on the description right now and can play the game even before looking at the whole tutorial. All right, so it says that the build is completed with results succeed 222 seconds. That's like more than almost 4 minutes. And after 4 minutes, it has actually created an HTML file and a couple of folders. You should put it on your web server, probably on an Apache server in a folder. How does that look like? Running on the website, you could probably see, I'll put a link in the description below, and you can run it from there and see how it works. The next thing we're going to do is move this project to Android. All right, to build this on Android, all you have to do is again go to File, Build Settings, and click on the Android. If you see many options, your Android support is installed along with your Unity. If that did not happen at the install time, you will see some other option. For example, you could see an option which will ask you to install. So on Android, I will go change a few settings for Android. For example, in the player settings, you will find a package name for Android. We need to change a few things. Run on the default device. I don't know, override default package name. Click on this, and this is going to be the Android package name that you use to put your application on the Google Play Store. So I'll call it com.mytutorial.mylabyrinth, and version number and all that is fine. First thing I need to do is click on Android and switch platform. Once again, this is a longer process, usually takes from 1 minute to up to several minutes. Is it done? No, it's working. So it's going to take some time to switch the platform to Android, and if it is once it is done, making sure that you change this, otherwise probably you may have some issues. You can build it to an APK file. As you know, APK file is the one that is needed to run on Android. Secondly, your default device should be connected through USB to your phone, but you will not have a keyboard on that. So what we need to do is make a slight change to the game. For example, if you are on the main scene, and instead of using your keyboard, you need to use probably your, it's gone too bright for some reason because of the Android texture shaders. Maybe I need to ease the lighting a little. I'll simply go select the directional light from here, and I will reduce its intensity from 1 to something less, maybe 0.85. It was a bit too illuminated for my liking, but this is not what I want to do. What I want to do is I want to rotate this board not with the keyboard but with the accelerometer. After fixing the light, one thing we need to understand is if I'm holding my phone like this, I want to use my accelerometer, and that accelerometer is going to work in a way that if my game is running in the landscape mode, then this up and down is my y-axis and right and left is my x-axis. So to play Labyrinth, we will hold the phone flat on its surface, and if I'm tilting my phone this way, it is going to be positive and negative acceleration on the x, and if I'm tilting this way, it is going to be positive and negative acceleration on the y. Also note that if I'm tilting too much to this side, this is going to be +1 acceleration, and this is going to be -1 acceleration. So there are no units, it's just +1 and -1. Similarly, on Y, it is going to be +1 and -1. So to incorporate this into our labyrinth and making sure that the accelerometer works with the code along with the keyboard, because there is a very rare possibility that somebody on the Android is actually using a keyboard. So it will work with the keyboard as well. So let's go back to the code. I will not remove these keyboard inputs, but I will go for a simple single line of code here. Transform.Euler angles. You should read more about Euler angles. This is about the rotation, x, y, z rotation of the object. So I will have a vector 3, which is a 3-dimensional vector, and I will give input.acceleration.y. And well, while the acceleration is 0 to 1, 1 degree angle is going to be too less. Maybe let's turn it into 20 degrees max. We don't change the z rotation, we change input.acceleration.x multiplied by 20, and I'll rather make it -20 so that it does not go in the opposite direction. So now when we run this on the phone, the accelerometer should give us the right movement. Let's see how it runs on the phone. Now there's a problem with the platforms. If you will run this code, it will always be 0, 0 on a desktop. So the rotation will not happen. So what we have to do is check hash if Android Unity underscore Android, then you then you run this line. Otherwise you run these lines. So if it is Android, we use the accelerometer, otherwise we use the keyboard. So now when I compile and run this, you will see the Android version in action. So let's see how it works. Now what I need to do is connect my phone using a USB cable, then go back to my Unity file, build setting. One thing I have to make sure that in my player settings, under the resolution and presentation, portrait modes are deselected. So portrait upside down and portrait rather landscape left should be the default thing. So only one rotation is possible. Once this change has been done, let me show you these options again. So by default, these all four are selected: remove portrait, portrait upside down, and landscape right, because I want the phone to be landscape left when I run the game. And now I will click on build and run. It will save Labyrinth as an APK, so I've just given the name. And now it is building the APK file. It still creates the APK while you're just asking it to directly put it on the phone. It will take some time to build. It will convert your Unity project into an APK, and this APK file will go onto your phone, and now it is copying the APK package to device. You can see once it is quiet, look at the bottom here, build completed with the result succeeded in 23 seconds. Now just to show you, I'll pull out the cable, and when I come up, you will see that this is actually loading the game on the screen, and you can see the Labyrinth is there. I'll probably use a better camera to show you this. So once we have done this, we have successfully run the game on the PC, on the web, and on a cell phone. I'm also putting a link to this game on the Play Store if you want to try that on your phone, and I'll also put the link in the description if you want to try that on the web, and probably I'll put an XZ as well. This is just a beginning. So if you think this tutorial was helpful for you, I'll be putting a link to a small course. You could actually sign up to the course and can do more detailed Unity 3D game development. You will be trained a large number of lectures, different type of games, also how 3D works, how 2D games work in Unity, how user interface is handled, how we use accelerometer and input devices and output devices. Please do go and check the content of the course. I'm sure you will actually find them useful. So that's all for this tutorial. I hope this was helpful, and I'll probably see you in another tutorial soon. Thank you.